Today, we're going to crack the code on how computers actually think. We're diving into how they make decisions and repeat tasks. I mean, this is the fundamental magic behind literally every single piece of software you use. It's the core of what makes a program, well, smart.
Have you ever really stopped to think about that? How does your music app just know to play the next song? Or how does a game character know to jump the instant you hit a button? You know, it's not magic, it's all about logic.
And that's exactly what we're breaking down in this explainer, the essential building blocks, the simple rules of the road that give software its intelligence. So let's dive right in.
First up, decisions. Look, before a program can do anything complicated, it has to be able to look at a situation and choose a path. This is like the very first step to creating smart, responsive code.
Okay, so the fancy term for this is a selection or a conditional statement. But all it is, really, is a structure that tests a condition. It asks a question. And based on whether the answer is true or false, it decides which chunk of code to run next. The easiest way to picture this is a fork in the road. The program gets to a point and has to make a choice. And our most basic tool for this is the if statement. It asks a really simple question. Is this thing true? If the answer is yes, it goes one way. If it's no, it just keeps on going down the other path.
Let's look at a super simple example. Here, the code sets a variable, num, to the number 6. Then the if statement asks the question, hey, is num greater than 0? Well, since 6 is definitely greater than 0, the condition is true, and boom, the program prints, it is a positive number. See, it's that straightforward.
But you know, life's not always that simple, is it? What if you have more than just two options? A simple fork in the road just isn't going to cut it. Programs often need to handle a bunch of different possibilities, and for that, we need a more powerful tool.
And the difference here is really important. A simple if handles just one condition, but an if, elif, else chain, that can handle multiple conditions, one after the other. It's like a path with a whole bunch of branches. The program checks the first if, then it checks each elif, which, by the way, is just short for elsef, one by one. If none of those are true, it falls back to the final else block. And this example shows it off perfectly. In this piece of code, the program first asks, is the number greater than 0? If that's a no, it moves to the elif and asks the next question. Okay, well, is the number equal to 0? If that's also a no, it just gives up and defaults to the else block, concluding the number has to be negative. It's just a really clean, logical way to handle three totally different outcomes.
All right, we've got decisions down. Let's move on to our second huge building block, repetition. I mean, doing things over and over and over again is what computers are really good at, and loops are the tool that makes it happen.
This whole process is called iteration, and we do it using loops. The key thing here is that loops save a mind-boggling amount of time and cut down on errors. Can you imagine writing the same line of code 100 times? No way. You just write it once and pop it inside a loop.
Now in Python, there are two main flavors of loops. You've got the for loop, which is kind of like a counter loop. You use it when you know exactly how many times you need to do something. Then you've got the while loop. That's your condition loop. It just keeps on going as long as a certain condition stays true.
So, let's look at a while loop. A great way to think about this is, keep stirring the soup while it's not boiling. In this code, the program is going to keep printing the value of x and adding 1 to it over and over, as long as x is less than or equal to 5. The moment x hits 6, that condition becomes false and the loop stops. And now for the for loop. This one is like being told, do 10 jumping jacks. You have a set number of repetitions, and that's it. Here, the range 111 function gives us a sequence of numbers from 1 all the way up to, but not including 11. The loop then runs for each number in that sequence, printing out its square. It's predictable, it's precise. And for loops are fantastic for working your way through sequences. This example shows how a for loop can traverse or kind of walk through a string of text. It takes the string hi students, and for every single character in it, it prints that character on a new line. It's a super simple but really powerful way to process text.
Okay, but sometimes just letting a loop run from start to finish isn't exactly what you need. You might want to skip a particular item, or maybe stop the whole thing early if you find what you're looking for. For that, we need even finer control over the loop's flow.
And we have two perfect tools for the job. Think of continue as the skip button. When the loop hits it, it just immediately jumps back to the top and starts the next cycle. Break, on the other hand, that's your emergency stop button. It doesn't just skip, it shuts the whole loop down right then and there. So
When a continue statement gets triggered inside a loop, the program's execution just jumps right back to the very beginning of the loop. It totally skips any other code that was left in that cycle and just gets on with the next one.
The break statement is even more dramatic. When its condition is met, the program gets kicked out of the loop completely. It immediately jumps to the very next line of code after the loop. It is an instant exit.
So we have decisions, and we have loops. They might seem like two separate ideas, but the real power, the real magic, happens when you start combining these building blocks to create useful, real-world logic.
Take a look at this great assignment program. This is a perfect example of putting it all together. It uses that exact if-else-else structure we talked about to check a student's marks and assign the right grade. If the marks are over 80, it's a grade A. If not, it checks the next thing. Are they over 49? Then it's a grade B. Otherwise, it must be a grade C. It's clean, simple, and incredibly useful.
So, let's do a quick recap of our new programming toolkit, shall we? For making decisions, we've got if, elif, and else. For doing things over and over, we've got while and for loops. And for fine-tuning those loops, we have continue and break. And what's so amazing is that with just these few fundamental tools, you can start to write code that isn't just a boring list of instructions. You can write code that actually reacts to what a user does, that repeats tasks efficiently, and that ultimately solves some really complex problems.
So I'll leave you with a little challenge. Think about your own daily routine. What's a simple task in it that you could describe using these very rules? You know, something like, for each of the 7 days in the week, if it's a weekday, wake up at 6 a.m., else wake up at 9 a.m. You see? This logic is absolutely everywhere. Thanks for watching.